Hi students, welcome to class 12 chemistry. Previously we have seen 3 units in physical chemistry, solid state, solutions and electrochemistry. Today we are moving to organic chemistry. I want to start my session with some warm up things for organic chemistry and then I gradually move into the unit. First let us start with the basics. So what is organic compound? Organic compounds are the compounds in which carbon is the main hero, along with it hydrogen, oxygen, nitrogen, sulfur and halogens are also present in some small quantities. What is the atomic number of carbon? That is 6. Electronic configuration of carbon, this is 1s2, 2s2 and 2p2, right. Before the formation of any compound, this carbon will get excited and one of the electron present in the 2s orbital will move to the 2p orbital. How it will happen? Like this, as per the Hund's rule. What is the Hund's rule saying? Hund's rule says that a compound or an atom should have at least half filled for a minimum stability. So, as per the Hund's rule, one of the electron from the 2s orbital is transferring to the 2p orbital. After this, the atom is ready to get bonded with some other things. Here, there are 4 hydrogen atoms with 1 electron in it will bonded with this carbon atom. So, 1 carbon, 4 hydrogen atom. What is it? That is methane. As a result, the carbon atom have 8 electrons in their valence shell. One more thing also we can say, it is a stable compound. This 4 is actually the valency of carbon. We should always remember the valency of carbon is 4. Now I am going to start with the hydrocarbons. What are hydrocarbons? Hydrocarbons are things which have carbon and hydrogen in them. So let me start with the normal hydrocarbon. Just put a bond between them. We know that valency is 4. So one of the valency is satisfied by this bond. So I am having the remaining valency as hydrogen. Here one valency is balanced by this bond and another valency is balanced by this bond. The rest of the 2 valency will be satisfied by the hydrogen bond. Here there are 2 hydrogen, here it is 3. So this is the butane, right? Yes. This is called as the alkyl. Since it is formed by a alkyl group, it is called as the alkyl and it also have the single bonds in it. So it is called as the alkyl saturated hydrocarbon. In a case of an alkyl saturated hydrocarbon, this is an open chain compound also. What does mean by open chain? We can see a terminal carbon atoms. That is, there are 2 ends. That is called as the terminal carbon atoms. If we are not able to see any terminal carbon atoms, then it is called as the closed chain carbon atom. Can you say any example for a closed chain carbon atom? What is this? This is called as the cyclohexane, right? Formula is C6H12. Now I am going to say about arene or aryl. So this both are meaning the same one. Arene or aryl hydrocarbon. In this arene or aryl hydrocarbon, the basic unit is benzene. What is the formula of benzene? C6H6. We know C6H6 contains alternate single and double bonds. So here comes the term unsaturation. So this is the alternate single and double bond. So we will start the structure like this. So I am drawing an alternate single and double bond. This is called as the arene or aryl hydrocarbon. Now, before going into the other classifications of the hydrocarbons, I want to say something about the hybridization. What is hybridization? Do you heard of mule? So, that mule is a peculiar example for hybridization. If you put some genes of a horse and if you add some other genes of a donkey, it will result in mule. Similarly, hybridization is the concept of mixing of some of the orbitals to result in some new orbitals. Here carbon can undergo several hybridization. The prominent hybridization we should know at this moment is SP3 hybridization, SP2 hybridization and SP hybridization. Here let us start with the SP3 hybridization. All the orbitals present in an atom are arranged in the order of the increasing energy level. So, I am drawing the carbon atom energy level diagram. This is 1s, 2s will be slightly higher in energy than this, and the next thing are 2p. Okay. So, I am drawn like this since the carbon atom will get excited as we seen earlier. So, this is the carbon atom. I am just drawing the outermost structure alone. So, in the outermost structure, outermost shell 1 2s electron and 3 2p electrons. I have drawn 4 electrons in the outermost shell. Now, this 2s orbital and 2p orbital. In 2s orbital there is 1 electron and in 2p orbital there are 3 electrons. This will undergo hybridization and form SP3 hybrid orbital. How this SP3 hybrid orbital will look like? It will be like this. Okay. This is the shape of the SP3 hybridized orbital. Each of course contain a single electron in it. After this hybridization, it may add with any group or hydrogen atom so that we get 8 electrons in the outermost shell, right. This is the SP3 hybridization. The angle between the lobes are found to be 109 degree 21 minute. This SP3 hybridization is actually seen in open chain, closed chain. Okay. Now, moving to the SP2 hybridization. So, how this SP2 hybridization start? I am drawing the same energy diagram. This is the 2p and this is the 2p. This is 2p and this is 2s. We are going to just concentrate on these things alone. There are 4 electrons in the valence shell. Here 1 2s orbital and 2 2p orbital, that is only 1 electron present in the 2s orbital and only 2 orbitals of the 2p orbital alone involved in hybridization. So, S and 2p will get SP2 hybridization. This is the SP2 hybridization. What happens to the remaining 1 2p orbital? This one of the 2p orbital remain unhybridized. That is, it does not involve in any hybridization activity. Do you know the shape of the 2p orbital? It is found to be a dumbbell shape, right? Yes. This SP2 hybrid orbitals will have an angle of 120 degree. The hybridized orbital SP2 have a shape of trigonal planar and the angle found between the lobes is found to be 120 degree. It will actually lie in a plane itself since it is a trigonal shape, and these hybridized orbital also having a unpaired electron in it. After this hybridization, any groups or any hydrogen atom will come and just interact with it, forming 6 electrons in the outermost shell. Only 6 electrons will be present in the SP2 hybridization. What about the remaining 2 electrons? Here this unhybridized 2p orbital have 1 electron in it. See, for a SP2 hybridization, we should know this SP2 hybridization have 1 sigma bond and 1 pi bond. Do you remember this sigma bond and pi bond? This sigma bond is just formed by the head to head overlap. This sigma bond is formed by just the head to head overlap of orbitals. This pi bond is just formed by the lateral overlap of orbital. So, now we are having 1 sigma bond and 1 pi bond in the case of SP2 hybridization. So, this is the structure, right? There is a double bond found between the 2 carbon atoms, and those 2 carbon atoms have 2 neighbors to it, right? So, this will be the thing, the one is sigma bond and one is pi bond. This pi bond will be formed between the carbon atom and the next neighboring carbon atoms. Remember, these 2 carbon atoms have equal energy. So, this unhybridized orbital of one carbon atom will laterally overlap with the unhybridized orbital of the another carbon atom, like this. This will result in the pi bond. This will result in the pi bond. You can see this SP2 hybridization as a beautiful diagram in the back cover of your book. Please see it. You can understand it more. I want to make you sure that you have to get an idea of SP3 and SP2 hybridization. So, I am saying you a trick to find out a SP3 hybridized carbon. If you see any carbon atom and that carbon atom have 4 neighbors. Yes, P3, 1 plus 3 it is 4. If there is 4 neighbor to a carbon atom, then 4 neighboring groups to a carbon atom. If there are 4 neighboring groups to a carbon atom, then the carbon atom is said to be SP3 hybridization. In case of SP2, 1 plus 2 that is 3. Suppose if there are 3 neighboring groups to a carbon atom, then it will falls under the SP2 hybridization. SP2 hybridization have a double bond also. This SP hybridization is result by the 1 s orbital and 1 p orbital, and 2 p orbitals will remain unhybridized. So, it will give 2 pi bond and 1 sigma bond. I am not going into detail in this SP hybridization, since I need SP3 and SP2 hybridization for this unit. I am stopping this. Okay. Now, this SP3 hybridization and SP2 hybridization is going to apply in the case of haloalkanes and haloarenes. First, we should know what is the haloalkanes and haloarene. Do you heard about alpha carbon atom? What is the alpha carbon atom? Any substituent or any functional group in which to which it is attached is called as the alpha carbon atom. Alpha carbon atom is the one which is possessing a functional group or substituent to it, then it is called as the alpha carbon atom. Here the substituent is actually chlorine, bromine or iodine. So, it will be called as the either haloalkenes or haloarenes. If this carbon atom is SP3 hybridized, then they falls into the category of this haloalkanes. So, open chain and closed chain hydrocarbons will have will have halogen attached to the sp3 hybridized carbon atoms. I am repeating it, the halogen is get attached to the sp3 hybridized carbon for open chain and closed chain carbon atoms. Is it clear? Next, that is arene, arene or arene. Here what is that? It is double bond. So, if we have a double bond, then we will say it as a SP2 hybridization. Yes, one of the halogen is going to be substituted in a SP2 hybridized carbon. If it is substituted in a SP2 hybrid, if the halogen is substituted in a SP2 hybridized carbon, then we call it as a arene or aryl hydrocarbons. In case of arene or aryl hydrocarbon, the substituent is attached to a SP2 hybridized carbon. Now, there are some more groups, we can see it one by one. The first one is allylic, the next one is benzylic, A, B. So, this both A and B have sp3 hybridized carbon atom. That is, the halogen is going to attach to the sp3 hybridized carbon atom. Now, I am drawing the structure for the sp3 hybridized carbon atom. We know it have 4 neighboring groups, is it? So, this is a halogen, here I am drawing a hydrogen. This is an example of, this is a small example for a allylic haloalkane. How we can say this as a allylic haloalkane? This is a halogen and this halogen is attached to a alpha carbon atom, and this alpha carbon atom is the sp3 hybridized carbon atom. This sp3 hybridized carbon atom is going to attach with the sp2 hybridized carbon atom, or in other words we can say the alpha carbon atom is attached to a double bond, then it is called as the allylic. We can draw this structure for a arene group also. Here this is the sp3 hybridized carbon. Remember, I am not drawing any benzene ring. This is just a cyclohexane, right? This is just a cyclohexane, and all the carbon atoms in the cyclohexane will be a sp3 hybridized carbon. I am having just a small alkene here. So, this sp3 hybridized carbon is get attached to a sp2 hybridized carbon, or we can say the sp3 hybridized carbon is attached to a double bond. This is the allylic group. The next one is benzylic group. Here in the benzylic group also the halogen is attached to a sp3 hybridized carbon. Here the halogen is attached to a sp3 hybridized carbon, but that sp3 hybridized carbon is attached to a benzene ring. Are you able to see the difference between the allylic and benzylic? In case of allylic, the alpha hydrogen atom is attached to a double bond. In case of benzylic, the alpha hydrogen atom is attached to a benzene ring. Okay. It is attached, the alpha carbon is sp3 hybridized, here also the alpha carbon is sp3 hybridized. In turn, the alpha carbon is attached to a double bond, means then it is called as allylic. Suppose the alpha carbon atom is attached to a benzene ring, means we will call it as the benzylic. What is this? Benzyl chloride. Next is vinylic. In case of vinylic, the alpha carbon atom is SP2 hybridized. SP2 hybridized means it have only 3 neighbors to it, right. So, one is satisfied by halogen and another hydrogen, and the next place we will be able to see a double bond. This is the vinylic group, CH2 double bond CH bond Cl. This is vinyl chloride. Okay. This is the vinylic group. So, there are these categories. Allylic, in case of allylic, the alpha carbon atom is sp3. In case of benzylic, the alpha carbon atom is sp3. In case of vinylic, the alpha carbon atom is sp2. In case of arene, that is benzene ring, there the hybridized alpha carbon atom is sp2 hybridized. Now, let us see the next classification, that is number of halogen atoms. As per the number of halogen atoms also the classification is going to take place. This is a monochloroarene benzene unit. This is a dichloroarene. There are 2 substituents. Here there is 3 substituents, so it is called as the trichloroarene. The next thing is monohaloalkane. Only one substituent, only one halogen is present. Here there are 2 halogen, but these 2 halogens are present in the carbon atoms nearest neighbors, right. There are 2 neighboring carbon atoms and those 2 neighboring carbon atoms possess a halogen each. So, it is called as the dihaloalkane. We have a special name for it. This is called as the vicinal. This vicinal can be write like this. What is this? This is CH2 double bond CH2, that is ethylene, right. If I am replacing one of the hydrogen atom by chlorine and one of the another hydrogen atom by chlorine, then this is called as the ethylene dichloride. We can also have a special name for it, is common name for it, alkaline dichloride. This one is trihaloalkane. There are 3 substituents in the alkane. One more special dihalo compound is there, that is a single carbon atom. The alpha carbon itself have 2 substituent halogen atom in it, means this is called as the geminal dihalide. This is called as the geminal dihalide, CH2 Cl2, called as the dichloromethane. Let me want to have a small overview of this whole session. Remember, we have two hybridization, that is sp3 hybridization and sp2 hybridization. In case of a normal saturated hydrocarbon, the halogen is attached just to a sp3 hybridized carbon. In case of arene or aryl hydrocarbon, the halogen is attached to directly to the ring. If the substituent is directly attached to the ring, means then the alpha carbon atom is of course to be a sp2 hybridized carbon. In case of allylic, the alpha carbon atom is sp3 hybridized carbon atom, and that sp3 hybridized carbon is attached with that of a double bond. In case of benzylic, the alpha carbon atom is a sp3 carbon atom, and that sp3 carbon atom is attached to a benzene ring. In case of vinylic, it is attached to directly to the double bond, that is the alpha carbon itself sp2 hybridized carbon. So, with this I am finishing my session, and we will go to the nomenclature in the next part. Thank you.